Hey everyone, Mr. Newman here, and I'm going to show you guys how to find the equation and graph circles. I want to build up the intuition of this a little bit, so let's start with the definition of a circle. First of all, you might not know it, but a circle is all the points that are a certain distance from a center point. So we call that distance the radius, right? And yeah, it's all the points a certain distance from the center point. So let's practice finding the distance. Well, find the distance from 0 to 3, 4. There are some teachers that show you guys, and there's this distance formula out there. I don't really believe in the distance formula, or rather I think it's too much to memorize. Instead, if you just recognize that as what you're trying to find and see it on a grid, you know that you can make a right triangle out of those lines, and you can use the Pythagorean Theorem to solve what that hypotenuse is, that distance. And I'm going to call it r. You'll see why in a little bit if you haven't figured it out already. But so the a squared plus b squared equals c squared. So 3 squared plus 4 squared equals r squared. We just solve for r and we get r equals 5. So that distance from 0 to 3, 4 is 5. Let's find the distance from 0 to negative 4, 3. I'm going to plot that point over here, negative 4, 3. Notice we make the same triangle, so we're going to be doing the same math. So I'm not even going to have you write it out. 3 squared plus 4 squared equals r squared, so r is again 5. Notice we do have negative 4 there, but the distances are always positive. And you know that negative, even if you plugged in a negative 4 squared is positive, so that distance is still 5. Now, notice there are a lot of other points that we could choose here. Anything that's 3, 4 or 4, 3, positive or negatives. 0, 5 is the distance of 5. All of these points, 5, 0, negative 5, 0, 4, negative 3, 4, 3, 3, negative 4. All these have a distance from 0 of 5. And these are just the integer distances, and you notice what we're starting to make. If I fill out all the distances, all the points that are a distance of 5 from the circle, from the center, we get a circle. So that means the equation of the circle is closely related to the Pythagorean theorem, and in fact, it looks very much like it. The equation for the circle centered at 0, with the radius 5 is any x and any y that fits that equation. We could have negative x because the squaring will make it positive, or negative y, but whatever x and y you plug in must fit that equation. And the reason is because that's how you find the distance from the center. Notice something, that 5 squared is 25, so x squared plus y squared does not equal the radius, it equals the radius squared. Well, what if we want a different center? Well, let's look at that. What I'm going to do is I'm going to make the center 3, 2, all right? And I'm going to pick all the points that are a distance 5 away again, because 5 is easy to calculate and it hits a lot of integers. So, for example, there's one point, there's another point. Those are all the horizontal and vertical distances, 5 away. Let's pick all the ones that are kind of our 3, 4 triangles. And I'm going to pick on this point right here. That was 4, 3, and now in the new circle that we've moved, it's 6, 6. So the idea is we want to think of an equation where if we plug in 6, 6, it's kind of like it does the exact same thing that 4, 3 did in the old equation. And I don't have that shown on the screen there, but you can look up at the old equation and figure out if that's what's going on. So let's do that together. First of all, it is going to be something squared plus something else squared equals 5 squared. That much stays the same. The question is what happens inside the parentheses. I'm going to go ahead and write down x minus 3. And my hunch of this is because, remember, when we plug in inputs, it does the opposite of what you expect. But let's go ahead and plug in the value 6 for x, the new value, and see what happens. Well, let's see. 6 minus 3 squared, that becomes 3 squared. Sorry guys, I just realized that this was, that point I had mixed up there. So that point was 3, 4 in the old scheme. So this makes a little more sense. So we plugged in 3 for x, we plugged in the new 6 for x, and we got out what was 3. Let's do the same thing for y. Let's make y be y minus 2. And if I plug in 6, the new value, notice what happens. It now becomes a 4. The old value, the previous value. And so all the rest of the stuff stays the same. So look right here. This was our old equation that we kept seeing over and over again. 3 squared plus 4 squared equals 5 squared. And the way we got that was by, when we moved the center, we subtracted 3 from the x and subtracted 2 from the y. Now notice, plugging in 6, 6 gives us 3, 4. The new 6, 6 value, now plug in this new equation, gives us what used to be 3, 4. Notice some other things about this. For example, if I had no idea what I was doing ahead of time, I would guess that having the center be 3, 2, we would say x plus 3 and y plus 2. But those values do the opposite of what you expect. Very much like when we were doing function transformations and we talked about the input. Both of those, in one sense, are inputs because, strictly speaking, this is not a function of y depending on x, right? If no circle passes the vertical line test. But if you think of both of these as the inputs and the radius as the output, we want to do the opposite of what we expect. So when we move right 3, we're going to say x minus 3. When we move up 2, we're going to say y minus 2. So there is our circle from that equation, and that is the equation of that circle. Let me give you the generic formula for the circle. It is x minus h squared plus y minus k squared equals r squared. And you've probably already figured out, but h comma k is the center, and radius is r. Let's do one tricky example here, because a lot of these are just plugging in and finding that generic formula or working backwards and saying what the center and the points are from the formula. So there's your formula. I want to write the equation for a circle with center -1, 2, and the point 3, 4 is actually on the circle. So we have our center, and we are given exactly one point that's on the circle. All right. Well, here is the formula that we have so far. With the center being -1, 2, we're going to write down x plus 1 and y minus 2. I don't know r yet, so I'm going to leave that as a variable. One thing we could do is we could measure the distance from the center to our point, and that would be our radius, and we could plug that back in. Here's another thing we could do, is we could just plug in 3, 4, because that's one of the solutions to our circle. And we can solve for r. So I'm going to actually do that because I think that's a little bit faster. So we plug in 3, 4, and we get the square root of 20 is r. So our answer is x plus 1 squared plus y minus 2 squared equals the square root of 20 squared. But we can simplify the square root of 20 squared in this case because the square root of 20 squared is just 20. So you really ought to simplify that and write it like this, where it just equals 20. Now notice the radius is not 20, the radius is the square root of 20. All right, thank you very much for watching.